Cool, recording in progress. Yeah, go for it.
I'll just share my screen. Just trying to get my monitors and notes and Zoom and everything organized. So can you see the slides? Is that all right?
Yep.
Okay, good. All right. Thanks, Patrick. I'm George from Team Magmo, and I'm here to talk about the work we've been doing productizing our software Go Nitro over the past 6 months. So this work was part of an open grant proposal that's funded by the Filecoin Foundation, which we're very grateful for. And yeah, just happy to share our progress. So I'll just dive straight in. The outline of today's talk is give a quick recap about our team, why micropayments, which is the kind of core proposition of what we're offering, are so important. And I'll also go over what our software offers beyond built-in payment channels, which is the mechanism you'll find in the Filecoin specification that's there to incentivize retrieval. And yeah, our whole thing is trying to improve on that mechanism. So I'll talk about where we were kind of 6 months ago, the middle of last year, what we did towards the end of 2022, and a little bit about what we've got in the works for the rest of this year. So we're Team Magmo. We work on layer 2 scaling, but state channels in particular, and payment channels. We've got lots of different outputs like documentation, POCs, white papers, blogs. But today I'm going to focus on Go Nitro, which is a software package we've been working on for quite some time now. And the title of the presentation should give you a clue. We're trying to turn this into a very mature product, fully featured, robust. So micropayments, let's take a step back. They're a really important mechanism that are enabled by state channels, and how they work and how they help to turbocharge things like retrieval, but many other use cases, is really interesting. So how do they work? You've got a payer on the right and a payee on the left. The payee is providing something to the payer. So it could be files, it could be some other kind of entertainment service provision of some kind. And what you do in micropayments is you split up both the service that's being provided and the payments that are going across in the other direction. And you just swap a little bit of one for a little bit of the other, relying on like what you might call micro trust. So you don't trust the other party much, but you do trust them a tiny bit. So you might send them 1 cent and they send you 1 kilobyte, something like that. And as long as that goes well, you can keep doing that. And you don't have to put much trust in the other party at all, because if they stop paying, you stop providing the service. If you stop providing the service, they stop paying. And you'll find this in the existing Filecoin spec. And it's a really general method to minimize trust. But the existing solutions out there often do still result in a lot of latency and cost in setting up these micropayments. And that's where Go Nitro can come in. So how might you do micropayments? Here's one way that you wouldn't do it. I've got the payee, the payer, and the blockchain here as different actors. And in the context, for example, of one retrieval deal in Filecoin, you could try and do micropayments on the blockchain. So every time you wanted to send a cent, you craft a blockchain transaction, sign it, pay the gas fees, broadcast it, and so on. But that's really awful, because the cost of doing the payments is so high that it's probably dwarfing the cost of the service. And even worse, it's just really, really slow, because each payment is massively slowed down by the block time latency, which might be something like 30 seconds on Filecoin. So that really doesn't work at all. If you have some vanilla payment channels, things are looking a lot better. So within the context of one retrieval deal, for example, the payer makes a deposit on the blockchain. That's still expensive and slow. And at the end of the process, the payee is going to do a blockchain transaction to claim those funds based on payments which are sent directly from the payer to the payee off-chain. And those purple payments are great, because they're essentially zero cost and they're essentially zero latency. All of those numbers are extremely low. So that's fantastic. And if you look at existing Filecoin payment channels, they're even slightly better than this, because you can set up a relationship between a payer and a payee, and you can do many, many retrieval deals using just one deposit and one withdrawal. But generally, you still have a bit of a problem that if you're connecting to someone new, you still have those red transactions up there, which are expensive and slow. So that's where virtual channels, which is what Go Nitro is built to execute, come into the picture. And the way they work is you still have these red, expensive, slow transactions, but they happen even less frequently in the typical flow. So you've got the same players up here, you've got the blockchain. Can you see my pointer, by the way?
Yes.
Yes, you can. You've got the blockchain here, the payer and the payee as before, and you've got a new player, a new party called the intermediary. And at the beginning of the process, both the intermediary and the payer deposit onto blockchain, and they're entering a state channel network. You can't really see that in this picture, but they're entering by making those deposits. And the intermediary is essentially guaranteeing some of the payments from the payer to the payee. And these two parties do not share any pre-existing connection, but because they're connected through the intermediary, they're able to transact in the end off-chain, which is a really powerful thing. So now in the context of a single retrieval deal, you just have to execute this virtual fund protocol in the green box between all three parties. And I can explain more about what that is. It's a completely open protocol. I haven't put it in a box to try and hide anything. I'm just simplifying. Once that's been executed, the payer can pay the payee, just like before, directly off-chain, very low latency, very low cost. And the main advantage over what I showed in the previous slide is these parties, as I said, do not need to have any shared deposit on-chain. They just enter the state channel network once. This could happen once a month. It could happen once a year. And once it's happened, retrieval deals can be started, executed, closed, and the payments all go through entirely off-chain. So that's a really great user experience. It means you can start doing this micropayment relationship very, very quickly and very, very cheaply. And that's, what we're really excited about. And Go Nitro is a software we wrote to execute everything in this box. Well, everything on this page really, but the complicated bit is the virtual fund protocol in the green box. And that's a kind of key thing that we work on. So 6 months ago, we'd already completed one grant. We'd implemented our off-chain protocols and built an off-chain client. And what that means is that virtual fund protocol here, we'd developed it in a sort of sandboxed way, if you like. We could test it, we could understand messages going between parties, but they weren't really being executed. Messages weren't really being sent from one person's computer to another person's. It was all like slightly mocked out. So our system could not yet talk to a blockchain. It could not yet send messages outside of its own process. And you couldn't actually send any payments. We didn't even have an API for that. And the final thing, we didn't really know if our system would be fast enough to power something like a CDN, like a content delivery network, where you need to have very, very low latencies for a good user experience. So that was a complete unknown to us 6 months ago. And since then, I'm pleased to say we've ticked all these boxes. So we've deployed our contracts to various blockchains, including the Wallaby testnet. We've built a proper messaging system using libp2p. We now have a payments API, which we've tested end-to-end, and we've got a benchmarking environment we've deployed, and we've done lots of performance optimizations. Sorry, was that a raised hand, Patrick, or?
No, that was just a clap reaction.
We'll take that. That's fine. Sorry, I thought it was a raised hand. So I'll go into a lot more detail about this in the coming slides. So firstly, the on-chain component. This was a big part of the work that we had to do in this grant. So I've got two important pull requests up here. On the left, it's an upgrade we made to our main adjudicator asset holding contract. And this upgrade is called Reclaim. That's not important what it's called, but what it does is it allows for state channel applications to be funded virtually in the way I described. So it enables that virtual fund protocol to be backed by something on chain. And that ensures that money pledged by intermediaries to guarantee payments can be safely recovered, even if parties in the protocol start behaving maliciously or go offline. So that's a really important step. On the right, we've got the on-chain rules for how payments are defined and sent. We chose to reuse a concept from Filecoin payment channels called vouchers. which is a very simple way of sending a payment, and we use the same data structure on what we're doing, so it makes it somewhat compatible. And the rules are kind of really nice, because if I go back to the sequence diagram here, they require all three parties, or in general, it's kind of n+2 parties. So you have any number of intermediaries you like. It could be a one-hop, single-hop payment channel. It could be hopping over 10 different intermediaries, and you have the payer and the payee. This virtual fund protocol requires them, all parties, to participate to set the thing up and also to tear it down at the end. But once that channel is created, it can be executed just between the payer and the payee. So the intermediaries have been completely like pinched out of the process. And this is one of the real big benefits of our protocol over things like Lightning payments or HTLCs that people might be aware of. In those other systems, every single payment would have to go through the intermediary, which would put a lot of load on them and slow the whole thing down. So yes, these two Solidity changes were really important, and the kind of common thing to both of them is that the code only really gets run in the unhappy path. So we've got to have it there, but we hope that it doesn't really get executed much. So that's, just to recap, code that guarantees funds from intermediaries and codes that defines how payments go through. Now, why doesn't that happen in the happy path? Because the messages happen off chain, and it's only when that process breaks down that you have to take the payments back on chain and claim them again. So actually, because our system is so optimized, in most of the time, you never even actually talk to the blockchain at all, which is kind of the whole point, because that's the kind of slow, expensive bit. So we've upgraded our contracts, which is great. They're available in NPM as part of the Nitro protocol package. And we also managed to deploy them, as I said, to Gurley. You can see the Etherscan link there, and also the Wallaby testnet, which is amazing. The Gurley deployment kind of worked out of the box, which we expected, because we've written this all in Solidity. But the Wallaby stuff had a few more teething problems, which we kind of helped the FVM Filecoin virtual machine team work through. And most of those issues have been tidied up now. So deploying is generally not an issue at all. Some of the end-to-end testing we've done has required some of the like more advanced features like events that took the team a little bit longer to get those working, but essentially all works now, which is absolutely fantastic, and really down to the hard work of the FEM team more than anything on our side. Really, we were just able to raise a few bug reports and have those fixed, so that was great. Next slide. Yes, payments. Here's another thing that I mentioned. Not a huge amount to say here. I'm just showing really the API that we put into Go Nitro. So we had a few unknowns in the design and the architecture of how to do payments. We weren't sure whether we would have consuming code, that is to say, applications written by third parties, actually sending the payments and handling that. In the end, we decided to bring it almost entirely all in-house. So we just have a pay function that people can call, and they pass in who they're paying and how much. And Go Nitro will craft the payment, sign it, send it to the counterparty, and they will receive a notification on this channel here, a kind of event stream saying you have been paid. And that stream is something that they could hook into to get that micropayment relationship set up. So they could, if you're a retrieval provider, you could kind of choke or unchoke the files you're sending to retrieval clients based on how much money they've sent you. And you just hook into this stream here to figure out when to do that. The next thing I want to talk about is the Testground system that we've set up. So Testground is a Protocol Labs project that we really love. And Alex, who's also on this call, has kind of been working closely with that team and using this tool to the max, really. So it's something we use to probe correctness and performance of our code. And it's something we can use to show off our progress quite nicely, actually. And we've integrated it into our development cycle quite closely. So you'll see here on the left, when anyone pushes a change to our repository, we'll get a Testground run kicked off. So what happens there? Well, we've got a cloud VM that's running the Testground environment. And what happens is it will pull the code from our repository and it will spin up lots of Go Nitro nodes. Some of those will be payers, some of them will be payees, and some of them will be intermediaries. Sometimes we call them hubs. And it will then have each of those nodes perform certain actions to set up a little state channel network. So they'll all get a connection to the hub, which we call a ledger channel. And then they'll use that to spin up these virtual channels running that virtual fund protocol. And then they'll send lots and lots of payments through those virtual channels, close them, open some more, and we run that for 60 seconds. And this kind of shows off lots of things, lots of functionality of our system that we've put in over the course of this grant. So we have, as I mentioned, the payments API is there, the messaging is there. So we're using libp2p over TCP transport to send messages out of the process that Go Nitro is running in, which is an important step. And various other things that I'm going to come to in the next slides. So another thing we
on that one just quickly.
Yes, sure.
Is there actually like a ledger running? Like, where are the ledger channels created on?
Good question. That's actually my next slide. So
okay.
What we did, so in the early days of the grant, we had something we called a chain syncer component, which was a bit of a hack we put in to try and simulate a blockchain. So the nodes would have transactions that have nowhere really to send them. So they just kind of gossip them around and everyone would kind of like pretend that there was a blockchain storing this information. So what we wanted was something running the Ethereum JSON RPC interface, because that's what the FVM roadmap ended up targeting. So we chose Hardhat, which is like a really popular development environment for EVM chains. And Mike from our team put some work in putting that inside a Docker container. And that was able to kind of seamlessly, well, not entirely seamlessly, but quite easily be absorbed into our Testground environment. We had to submit some work into the Testground repo itself, building on some stuff that Hannah Howard had built. And we just kind of got that over the line and were able to get Hardhat in the environment too. So all of our Go Nitro nodes actually send transactions to Hardhat inside Testground. So that's where all the deposits and withdrawals happen. And that's great because it's exactly the same interface. It means once we have it running successfully against Hardhat, it's basically no work at all to plug it into something like Wallaby. And we've actually done that. So we can run this quite extensive integration test against a real blockchain like Wallaby. And, you know, very soon in the next couple of months, we're going to be running that against Filecoin mainnet. So that's really exciting. The other amazing thing about Testground is that we get these beautiful dashboards that Alex has constructed. So not only do we have runs that go on every commit, but we also have a nightly run, so we can kind of track changes over time. And each run that gets executed, we have a bunch of metadata about it, as well as a bunch of statistics that we gather. So this run here, you've got a run ID, which essentially matches a commit in our repository, and various parameters that we set, like the duration, the number of actors. We also have some traffic shaping, which is something built into Testground. It's really easy to use. So we have the messages delayed with these two parameters here. So there's a kind of 10 millisecond latency and a 1 millisecond jitter, which is kind of representative of a reasonably healthy but realistic network, I suppose you might say. We've had a lot of fun making it a lot worse, and we can investigate what happens, you know, in the really optimistic case where there's zero latency. Those things are interesting, but we picked something we thought was reasonably realistic to gather some numbers. And the big yellow number there is TTFP, time to first payment. So that's essentially measuring the time it takes to run the virtual fund protocol. And this is an important number because it's the delay between finding someone, if you like, with your file in the retrieval market and starting that relationship to when you can send them money to when they're going to send you back the file that you're looking for. So something like 100 milliseconds is not bad. We were pretty pleased with that outcome. That's not to say we're entirely satisfied with it, because we, as part of our grant, we were looking to make performance improvements, because this is a key number for us. So I'll circle back to that. In fact, I want to circle back to it. So my next slide, talk about it now. So as part of the grant, we also looked like long and hard at our code and found a couple of performance optimizations, which are kind of interesting. And I'll talk about them in detail, but the kind of high level thing you might notice from these diffs is that they're like one-line changes, which is kind of interesting. We managed to get some improvements just with these two very, very small changes. And I think they're kind of testament to the work we've done to design a way of writing protocols in a nice, easy to understand, easy to edit way. And also it's testament to the fact that we're using Go, which is a good language for concurrency and optimizing performance that way. So the first change is that intermediaries can exit the virtual fund protocol early. So we had a look with pen and paper, if you like, at our virtual fund protocol, and we try to trim some of the fat out of it. We try to think what's really necessary and what's just like feels right. So we just do it without thinking. And one of the things we identified is that there's a certain step where Alice and Bob need to wait. It's very important for them to wait on certain information coming in from the other parties before they start sending payments. But the intermediaries don't need to wait because they don't have as much at stake, or not in quite the same way. So by making this one little change here, basically checking if you're Alice or Bob, which is the payer or the payee. If you're Alice and Bob, you do the waiting step. So you kind of wait a bit longer. But if you're neither of those parties, you could be the single intermediary, or you could be one of the 100 intermediaries and 100 hot payment. You get to finish a little bit early. So you get to quit the protocol and go ahead and do some more work on maybe a different virtual fund protocol with different participants. So that's one little change we made. And the second one, we decided we could send messages concurrently. We didn't have to wait for one message to be sent before we started work, sending the next one. And putting those two things together, we got like a 25% reduction in the time to first payment. So we brought it down to 80 milliseconds, which makes it go green, and everyone knows green is good, right? So yeah, we were kind of happy with that, and that shows a really nice improvement in the performance with the same network traffic shaping. So yeah, I just rearranged everything I just said into a slightly different kind of lists to make it a bit easier to skim through compared to our grant. So we upgraded our adjudicator contract and we deployed it to an EVM chain. We also deployed and benchmarked a test network, which included production messaging and dashboards. We also upgraded our adjudicator contract. I mentioned that already, but we deployed it to the Wallaby testnet, which was really good fun and really interesting. We did the Go Nitro payments API. We built a production chain service, and we reduced the time to first payment by making performance optimizations. So that's pretty much my presentation done. I just thought I'd give a little bit of a hint about what we've got coming up next. Some of the things we're looking at doing in the next 6 months, we haven't completely settled on our roadmap, but here's just a flavor. So we're going to have our contracts on Filecoin mainnet. Again, that's more work that the FVM team are going to do rather than us, but we will be there for the ride, and we hope to be some of the first contracts deployed when that FVM lands on mainnet. Super exciting. We'll upgrade Go Nitro so that it can cope with peers going offline, which is something it can't currently do. There's a bit of a hidden assumption there that everyone's online all the time. It's not something our core protocol requires, but our software doesn't currently handle that happening. Everything would just slow down to a halt. So we're going to build the module that handles that situation. Similar to this, we're also going to cope with a loss of power or crashing. So one day you'll be sending payments using our protocol from your smartphone, and if you run out of battery, we don't want you to lose money, or we don't want you to have to go to the blockchain unnecessarily. We want you to be able to charge up your phone, restart it, and just pick up where you left off. So that's another thing we're looking at. We're going to enhance what we're doing with Testground to look at distributed deployments at scale. So we've done something on a single machine with Dockerized instances, on the order of 5 or 10 nodes. Testground can take us far beyond that to thousands or tens of thousands of nodes. So that's something we are really interested in trying out. And it's also, as I said before, just a really good way of showing off some of those other things. So we'll be able to run Testground instances and then start killing off nodes and checking that everyone else recovers. Yeah, other things we're looking at are integrating with things like Lotus client, because we want to get our system in there powering real retrieval deals. And lastly, we're looking into doing an RPC interface around our software so that you can access it from more different environments and more different languages, including in the browser, and not just constraining people to writing applications in Go. So yeah, that's the end of my presentation. I've got this final little slide about where micropayments fit in the retrieval market. So talking about integrating with Lotus, that's kind of in this situation. So Patrick, you'll recognize this diagram. It's kind of similar to ones you draw quite a bit. And I've tried to sort of zoom in on where I think micropayments will fit the best. So here you've got Lotus storage miners. These two Saturn nodes are kind of sitting on top as a secondary market. And this relationship here is a bit tricky for us to put micropayments into, because Saturn L1 nodes are sort of being paid by content publishers, but the data is going somewhere else directly to the users. So we don't have those like crossed arrows relationship where micropayments make the most sense. So we're going to concentrate more on the relationship between the kind of lower levels of the Saturn network and the actual sort of source of truth big database that has everything, which is the Lotus, the Filecoin network itself. And also between Quarry, which is an interesting project, which we think micropayments will be a good fit for, where you've got like clients running in the browser who need to get blockchain data from Lotus nodes and are willing to pay for that. So yeah, that's where we've kind of identified that we'd like to sort of work and integrate our system next. Yeah, and that's the end of the presentation. So I'm happy to take any questions.
Yeah, thank you so much. Great presentation as always. They always look beautiful from the Magmo team. Just really, really easy to understand and simple, and just going through it step by step. So thank you very much. On this diagram, makes complete sense. I think that, yeah, that's exactly, you identified the kind of the Saturn flow from content publishers to the users. That's kind of covered, I suppose, by the Saturn payment mechanism. But as we go a little bit further down the levels, the micropayments become much more of a good fit. And then Quarry, as that starts to gather momentum, that's definitely a good fit as well, because it's going to be much more in this sort of, just completely trustless model, where the micropayments are a much better fit, really. Super exciting to see that the work like all the work you guys have done with the FVM team, and how we're going to be getting smart contracts out pretty quickly after launch. And I think that just shows as well that it almost puts this whole project into the position where kind of, I guess, higher level teams can use it as a building block and say, hey, we need this as part of our solution. And it's almost just like an out of the box thing they can drop in as part of one of perhaps their smart contracts, and then like even every layer of the stack now, as you start to explore how it could integrate with the browser. So yeah,
that's right. We're actually thinking of there's a spaceport hackathon going on this week and next, and we're going to try and do a workshop where we can encourage people to build on top of Nitro for whatever application they might be thinking of building. So yeah, that lines up what you said.
Yeah, that's a great point. And in these hackathons, buildathons, I think they do have a kind of toolbox part of it where they say like, oh, these are the tools that you can hack around with. So if we can get this into that list, then people are going to start understanding what it is, hacking around with it, and we'll just start to see it appearing as a dependency in more dApps, I guess. That's really exciting.
That's what we're aiming for. We actually have some kind of material already that Colin produced for a project called Speedrun Ethereum. I'm not sure if you've heard of it, but it's effectively like a kind of tutorial system that you can do on Ethereum. And once you get a long way through and you're like a seasoned, or you're like a beginner Solidity developer, you get onto the state channels challenge, and you have to build a little peer-to-peer state channel system, and Colin put that together.
Cool.
So we're hoping we can kind of repurpose that a bit, and have people at the hackathon maybe take a look at it, or yeah, to be confirmed, but yeah, it'd be really nice to do that.
Nice. One question then, did you get any further with your thinking around, and I might have just missed this because a lot of information to take in, do you get any further with your thinking around how the hubs would be incentivized?
Yes, we have got a bit further with that. I don't think we've got the final answer, but we spent some time thinking about how they could extract fees from this system. And we want a few things from that mechanism, I suppose. We want it to be a kind of open protocol, if you like. So intermediaries should be able to set the fees that they want in the fee mechanism. So they may charge some kind of flat rate for opening a virtual channel. They might charge per payment. There's lots of different models they can do. So we wanted to enable it to be as open as makes sense for people to charge the fees that they want to charge. But then on the flip side, we want to make it impossible for people to lose money, for example, by doing things incorrectly. And we also want to take account of, what are the opportunity costs for intermediaries? How they expect to be compensated for what they're doing? So if you think about what intermediaries do, they lock up capital for a certain amount of time. So ideally, you'd want intermediaries to be compensated per unit time, but that's a bit tricky with state channels. And if you're not careful, you introduce new incentives for bad actors who may wish to like keep a channel open for longer than is really necessary, or maybe they want to open the channel, close it immediately because that would enable them to earn more money. So there's a few corner cases and things like that to work out, but we think we're close to a mechanism where intermediaries basically get paid a percentage of the money that they stake on these virtual channels. So that's coming soon.
Awesome. Cool. Yeah. Just let me think. I'm now just kind of thinking through anything else. That's super cool that the like sub 100 milliseconds, even though that's 100 is, I guess, just an arbitrary number, it is, so it's quite fun to break below the three figures.
Exactly. Yeah.
So that's super cool. Nice. Yeah, it looks great. I think I'll take some more time to kind of just perhaps watch it again and just dive into some of the PRs and stuff, just to get a little bit more in depth. But that looks great.
Excellent. I can also share the slides, and
that'd be lovely. Yeah, that'd be great. Thanks.
If you need any more information, I can provide links and all that kind of stuff. All of our stuff is fairly open and easy to find. But yeah, do let me know if you want any more pointers.
Okay, cool. I'll stop the recording now, just so we're not being watched.